Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Iza Iqbal, and in this video, our group will present about nuclear reaction. Our group member is Muhammad Imran bin Cik Murad as a leader and Muhammad Firdaus bin Ilyas. In this video, it will contain introduction, self-awareness, and social responsibility. Let's go to the introduction first. A nuclear reaction is a process that occurs when a nuclear particle, which is nucleon or nucleus, get into close contact with other. Most of the known nuclear reactions are produced by exposing different material to a beam of accelerated nuclear particle. Usually, strong energy and momentum exchange take place, and the final product of the reaction are one, two, or more nuclear particles leaving the point of close contact in various directions. The products are mostly of a species different from the particle in the original pair. Reaction energy. Energy is released, liberated in nuclear reaction in the form of kinetic energy of the particle emitted, the kinetic energy of the daughter nucleus, and the energy of the gamma ray photon that may accompany the reaction. The mass defect is equal to the submission of mass nucleus before reaction minus the submission mass nucleus after the reaction. The reaction energy Q is the energy equivalent to the mass defect delta M of the reaction. Thus, Q is equal to delta M times C squared. There are two types of notable nuclear, which is nuclear fission reaction and nuclear fusion reaction. The former involves the absorption of neutron or other relatively light particle by a heavy nucleus, which causes it to split into two or more lighter nuclei. Nuclear fusion reactions are the processes in which two relatively light nuclei combine via a collision to afford a single heavier nucleus. How nuclear reactor work? The main job of a reactor is to house and control nuclear fission, a process where atoms split and release energy. Reactors use uranium for nuclear fuel. The uranium is processed into small ceramic pellets and stacked together into sealed metal tubes called fuel rods. Typically, more than 200 of these rods are bundled together to form a fuel assembly. A reactor core is typically made up of a couple hundred assemblies, depending on power level. Inside the reactor vessel, the fuel rods are immersed in water, which act as both a coolant and moderator. The moderator helps slow down the neutron produced by fission to sustain the chain reaction. Control rod can then be inserted into the reactor core to reduce the reaction rate or withdrawn to increase it. The heat created by fission turns the water into steam, which is spin a turbine to produce carbon-free electricity.
Next part is about the self-awareness. First, why nuclear reactor is dangerous? So, nuclear reactor is dangerous because nuclear reactor will cause widespread contamination of air and water. Nuclear energy will produce radioactive waste such as uranium that will harm to human health on the body. How does nuclear radiation harm the body? As radioactive materials decay or break down, the energy released into the environment has two ways of harming a body that is exposed to it. It can directly kill cells or it can cause mutation to DNA. If those mutations are not repaired, the cell may turn cancerous. Radioactive iodine tends to be absorbed by the thyroid gland and can cause thyroid cancer. Children are most at risk for thyroid cancer since their thyroid glands are 10 times smaller than those of adults, which the radioactive iodine will be more concentrated in them. This concentrated energy causes the molecules in our body to react in ways that can be extremely damaging, sometimes giving rise to cancer. So, why nuclear reactor is important? A nuclear reactor is the most important part of a nuclear power plant. It is where the nuclear chain reaction occurs that produce energy by fission. The heat thus produced can be used to produce electricity. The main purpose of a reactor is to contain and control the energy released. Uranium is used as the nuclear fuel in the reactors. The heat produced by nuclear reaction is used to convert the water into steam, which is further converted into carbon-free electricity with the help of turbines. The importance of the nuclear power industry to the nation's energy security is becoming increasingly clear. Nuclear energy is the only large-scale, carbon-free electricity source that the country can widely expand to produce large amounts of electricity. Nuclear power plants prevent the release of significant quantities of emission that would be created by burning fossil fuels to generate the same amount of electricity. Then, there are several advantages and disadvantages of nuclear reactor, which for its advantages including carbon-free electricity, small land footprint, high power output, and reliable energy source. While for its disadvantage, uranium is technically non-renewable and is very high upfront cost and it will produce nuclear waste. Then, malfunction can be catastrophic.
A major environmental concern related to nuclear power is the recreation of radioactive waste such as uranium, uranium, spent reactor fuel, and other radioactive waste. This material can remain radioactive and dangerous to human health for thousands of years. Radioactive waste are subject to special regulation that govern their handling, transportation, storage, and disposal to protect human health and the environment. Radioactive material in the plant from the nuclear power plant can settle and contaminate people who are outdoor, marine, food, water, and livestock. So, radioactive material can also get inside the body if people breathe it in or eat or drink something that is contaminated. People living close to the nuclear power plant who are exposed to the radiation could experience long-term health effects such as cancer. A preventive solution to develop a new plant is invasive vegetation, which intends to stop the propagation of methane by automatically flooding the reactor pit with water if the system detects a rising temperature in the core, reducing the risk of human oversight. IVMR can help reduce the risk of nuclear meltdown, but if this occurs, it won't completely eliminate the risk of contaminating the environment. It would have to be combined with other safety measures to, to maximum the level of safety. Responsibility would then rest with utility companies who implement these safety measures. However, this can be difficult in the light of the very large investment to build a nuclear power plant as well as for the general cost during its lifespan.